Greetings, class. The purpose of this video is to give the background information on Whitlock Schluter Chapter 1 that we can all have as a foundation before we come to class. Now, as we've said, statistics is the science of data. We're always talking about populations. Let's say we have a random variable x, which is height. Okay, this variable x has some unknown mean mu. And what we do is we collect samples out of the total population, which is this big circle here. And we're going to get a sample. And in that sample, we'll collect, let's say, the sample mean to try to estimate the population mean. Now, this enterprise, I'd like to point out, is a very biblical enterprise. For example, in Proverbs chapter 2, I'm going to start here at verse 4. We're talking about wisdom. If you seek wisdom as silver and search for her as for hidden treasures, then you will discern the fear of Yahweh and discover the knowledge of God. And that's typically what we're doing in our university studies at Biola, is seeking wisdom, seeking to know the truth about the world, and ultimately it turns out to be personal. Amazing. Now, the random variable is the thing we want to measure. What we're going after is the experimental unit. If I measure, let's say, UCR students' heights, then the 69 students that I get in my sample is their, the 69 students are the experimental units, and the observations that I get from them are the data. The collection of all those data points, including possibly other variables, is the data set. Now, if there's a systematic mismeasurement, that's bias. For example, if I was using a stretched out tape measure that when it said 5 feet, it was actually 5 foot 4 inches, let's say, because it was stretched, those would be biased measurements. On the other hand, if I let each student measure another student, and then I collected all those measurements, and suppose that the tape measure was only accurate to 1/2 inches, but I required them to measure to 1/4, they're going to be taking some guesses, and some of them might not line rulers up on heads correctly and stuff. You're going to get variability. Okay, that's different than bias. That's just going to go up or down depending on the student. Now, I actually collected such a data set here in 2004 from a UCR class that I taught. And I'd like to consider this data set. We're going to look at height, hair color, major, and study hours. I've got the data on RStudio, and if you go over to loading your data up, click on the UCR tab, we're going to consider some of those variables. We'll focus in here on the first few. Now, bias, I'm not too worried about for height, because I think everyone accurately reported their heights. So not on height. On the other hand, we might get some bias on weight, because this was taken in class. The papers were passed forward, and you can imagine that some students might not have wanted to have others possibly see their weights as they were going down the row. As far as error, there's going to be natural variation. In height due to biology. There could be variation in height due to mismemory. Let's just suppose students didn't remember it accurately. Okay, those would be two possible sources of error in the height measurement. Okay, now what I'd like to point out is that this form of bias and then variation are two manifestations of the two of the three big ideas in data sets, namely measures of center and measures of spread. So the idea behind center is how close you are to truth. The idea behind spread is just how close individual observations are. There is typically going to be variation there. Colloquially, if we're near center, we're referring to accuracy. And as far as spread, if we have little spread, we call that precision. Okay? From a statistical standpoint, we talk about measurement error and bias. So I'm going to put bias and then measurement error. And then as far as spread goes, we're talking about variability. Okay, now from a psychological standpoint or sociology, their measure for center is it valid? In other words, is it accurately representing the truth? And then how much variation is there? They refer to reliability. Again, these all group under the same two concepts. There are some specific statistical terms for center we will explore later, which will be the mean, median, and then the mode, M-O-D-E. These are three measures of center. Measures of spread, we're going to look at range, and then standard deviation will be our main one we use. Okay. Now, let's just get a few more definitions out here. Categorical variables are when the values of variables are categories. Okay. And let's see, numerical variables are when the values of variables are numbers. These are the primary two kinds, in fact, they are the two ways that we can get data, either categories or numbers. And within categories, we're going to distinguish between nominal, that is categories that have no order, and ordinal variables. So, for example, I'm going to bip over to my RStudio, and if I take and attach my UCR file, and let's look at hair color. I put a 2 after it. Those are the hair colors. I got black, brown, dark brown, and so on. That's nominal. There's no natural ordering. Height, of course, is a numeric variable. Those are all numbers. So we've got hair color. Major is another one. Most variables you think of, their categories are probably going to be nominal. But here's an example of an ordinal. Let's do a 5-point Likert scale, where maybe you're filling this out for some survey or something, and you'll have the choices of strongly disagree. You might have disagree. You might have neutral, and then we'll have agree, and then strongly agree. Those are categories, but they're ordered, and so that gets me the ordinal label. Okay, you can read a little bit about that here. Now, mathematical types of a random variable, this is another way to classify variables, and discrete is simply countable. Okay, so categorical variables are discrete, and then numeric with integers. Okay, so for example, we could say the number of cars in the parking lot. Okay. On the other hand, a continuous variable is one that could go on a continuum. So for example, height, if we're talking about 0 to 7 foot tall, then anything in there could count. You could count fractions of inches. And therefore, between any two heights, you could always find another height that's continuous. All right, let's see. Relationships between random variables. Let's go to table 3. Okay, moving to table 3, I've got it popped up right here. And x is the explanatory variable. Y is the response. Okay, explanatory response. Now, causal relationship, think of x as the independent variable and then y as the dependent variable. Okay, for example, if you had two numeric variables, maybe one of them is the height of, let's say, parents, let's say x, and then y is the height of the children, both numeric, you could get some type of scatter plot coming out of that thing. Okay, so we think of x as the input, start off with that functionally, and then what do you get as the output? Let's not do this. If you're in a social science context, then we tend to think of an intervention. What's the intervention? If you're in medicine, they refer to that as the treatment. All the same thing. Maybe it's a particular therapy or form of surgery that's new. If you have an intervention variable, then the response is called the measurement variable. And then if you have a treatment, the response is called outcome. Again, these are all just x and y. In a proper statistical design, we call x the factor. And that covers the first part of these notes.